Okay, 1993, number 21, points of inflection. You should know that's when the second derivative changes signs, so we need to find the second derivative. For that, I'm going to rewrite this because I can't take the derivative the way it is, so I'm going to rewrite it like that. So the first derivative, we bring the -2 in front and decrease the power by 1. We bring the -3 in front and decrease the power by 1. And so let me rewrite this, -2x -3 plus 3x -4. Then the second derivative, we do the same thing. We bring the -3 in front, decrease the power by 1. And we bring the -4 in front, decrease the power by 1. And I think it's the algebra that might kind of mess with you here. So we're going to have positive 6 over x to the 4th minus 12 over x to the 5th. Now to find the points where the second derivative could change signs, it's going to be where it's 0 or undefined, the second derivative. So I want to get a common denominator and make this one fraction. I wish they both were x to the 5th. Well, I can do that by multiplying by 1. There's my 1. So this is common denominator of x to the 5th, and I'm going to have 6x minus 12. That is my second derivative. Where can the second derivative change signs? When the second derivative equals 0. When does the second derivative equal 0? When the numerator equals 0, or 6x equals 12, or x equals 2. That's one possible location. The other one is when the denominator is 0. In other words, the second derivative is undefined. And when x to the 5th equals 0, clearly that's x equals 0. So those are the 2 points where I could have an inflection point. So what do I do? What's the, whoa, undo that move. What's an inflection point? It's a point where the second derivative changes signs. So I need to find out if the second derivative changes signs at those 2 points, at 0 and 2. And to figure that out, I need to plug in values around that and see if the second derivative does change signs. Let's plug in -1. -1 times 6 is -6 minus 12, that's -18, over -1 to the 5th, which is negative, and 2 negatives make a positive. So I know the second derivative is positive at -1. Let's plug in 1. 6 times 1 is 6. 6 minus 12 is negative. Over 1 is positive. A negative and positive make a negative. And then let's plug in 3. 18 minus 12 is positive, and 3 to the 5th is positive, and 2 positives make a positive. Therefore, I have 2 inflection points, at 0 and at 2, because the second derivative changes signs at those 2 points. So at what values of x? Oh no, I have to explain why it's not going to be 0. I am a lame-o, and that's my name-o, because I didn't notice this. Can you plug a 0 here? No, the function does not exist at 0. If it doesn't exist at 0, there can't be an inflection point because the point doesn't exist. So therefore, I shouldn't have even considered 0. So the answer is 2. The answer is 2.